Hello guys, let's solve the following physics problem, mainly about vectors. Find the magnitude of vector W in this figure. To begin, let's note that the sum of vector U with vector W is vector B, but to find the value of W, we need to decompose each vector into its x and y components. Since the sum of the vectors in the x-axis is equal to the magnitude of the resulting vector, and similarly in the decomposition of vectors in the y-axis. However, for the decomposition of vectors in the x-axis, we use the cosine of the vector's angle measured counterclockwise multiplied by the magnitude of the vector. To decompose it in the y-axis, we use the sine of the vector's angle measured counterclockwise multiplied by the magnitude of the vector. Using the calculator for support, we obtain the following. For vector u, here we have vector u, and we note that it has 30 degrees and counterclockwise, a magnitude of 8 newtons. So x-axis 8 newtons times cosine of 30 degrees, and this one is equals approximately 6.9 newtons. Y-axis 8 newtons times sine of 30 degrees, and this one is 4 newtons. For vector W, we don't know its exact magnitude or angle, so we simply denote them as W and alpha. W and alpha. So we have x-axis W times cosine of alpha, and y-axis W times sine of alpha. Finally, we decompose the resultant vector, the vector B. To the x-axis, 7 newtons times cosine of 80 degrees is approximately 1.21 newtons. Y-axis, 7 newtons times sine of 80 degrees and is approximately 6.89 newtons. Well, it is known that the sum of the individual components of each vector in the x-axis is equivalent to the x component of the resultant vector. So we have 6.9 newtons from here plus W times cosine of alpha from here. This one must be equal to 1.21 newtons of the vector the resultant vector, sorry. Well, I will call this equation 1. Let's continue. Similarly, it is known that the sum of the individual components of each vector in the y-axis is equivalent to the y component of the resultant vector. So we have 4 newtons from here plus W times sine of alpha here. This one must be equal to 6.89 newtons from here. Let me call this equation 2. I will solve for W in both equation 1 and 2. Proceeding 1 W times cosine of alpha is equal to 1.21 newtons minus 6.9 newtons. This is equal to minus 5.69 newtons. Well, the cosine, which is being multiplied, moves to the other side of the equation, dividing by this number. And we have this. And 2 W times sine of alpha is equal to 6.89 newtons minus 4 newtons. This is equals to 2.89 newtons. Similarly, the sign that it's being multiplied moves to the other side of the equation, dividing this other quantity. No? Well, equating the values of W, this one with this one, we have that. We have this. And now the sign of alpha moves to multiply the other side of the equation, and minus 5.69 newtons moves to divide the other side. And here. Since sine divided by cosine is equal to tangent, and newtons here and here cancel out or simplify, we get tangent of alpha is equal to minus 0.507. Applying the inverse function with our calculator, alpha is equal to arctangent of minus 0.507. We have alpha is equal to minus 26.92 degrees. But considering the diagram and expressing the angle in a better way, from here, we add 180 degrees, a half turn. Why? Because this make more sense. Since we are working with positive angles measured counterclockwise, and that's the reason. So alpha plus 180 degrees is equal to 153.07 degrees. Now we just need to evaluate this angle in any of the W expressions. This or this. Well, using equation 1, this one, we have W is equal to minus 5.69 newtons divided by cosine of 153.07 degrees. Then W is equal to 6.38 newtons. Yay! Well, and verifying with equation 2, this one, W is equal to 2.89 newtons divided by sine of 153.07 degrees. We have the same. W is equal to 6.38 degrees, which is our answer. Therefore, the correct answer is option A, as it is the closest considering error margins. Well, guys, this is all. And finally, let's let's continue next class. Bye bye.